Hi, what do you know about pi? You know the number 3.1415 and so on, a number that seems to go on forever, and there are many people that try to memorize as many of the digits as they can. Here is pi correct to 50 decimal places. What else can we say? We can also say that pi is the ratio of the circumference of a circle to its diameter. That's probably something you've learnt from your work on perimeter and area of circles. Now let's see how we can start the problem off in terms of Monte Carlo simulation. Look at that rectangle. Half of it is blue and half of it is green. Let's suppose we have 10 tennis balls that we wish to throw at that target. How many of them would we expect to land on the blue and on the green? Because half of it is blue and half green, we would expect that 5 of them would hit in the blue section and 5 in the green. But we know from experience that does not always happen. But let's simulate the situation. There's the first one. And we have all 10 there. If we take the ratio of the number that have landed in the blue, 4, over the total number 10, then the ratio is 4 over 10. And similarly for the ratio of the number that land in the green section, 6 over 10. Now we come to obtaining an approximation to pi using what we call Monte Carlo simulation, which I mentioned just a moment ago. Basically, it involves modeling behavior or an event or an outcome using random numbers when it would be difficult to do it in any other way. In other words, if we simulate a situation using probabilistic methods over a certain number of trials, we can get a picture of what is actually happening. Now in this diagram you can see that we have a circle inside a square. The radius of the circle we can call r, and therefore the side length of the square is 2r. We know the area of the circle is pi r squared, and in this case the area of the square will be 4r squared. If we take the ratio of the area of the circle to the area of the square, we have pi r squared over 4r squared. We can cancel out the r squared and we're left with pi over 4. As an estimate in terms of the number of hits, or let's say tennis balls, that we throw at the shape, we can get an estimate in terms of the number that hit the circle and how many do not hit the circle. In other words, the ratio area of a circle to the area of the square, we can say, can be approximated by the ratio of the number that hit the circle over the total number. And from that, we can have an estimate for pi, which is 4 times the ratio, circle hits over square hits. Now, I've developed a computer simulation program that we'll look at in a moment that works on the same idea. The first image you can see there, I've used 100,000 trials. Looking at the bottom of the screen, you can see that the estimate comes out to be for pi 3.14744, which gives us a relative error of 0.19%, which is quite small. Then with 500,000 trials, the estimate becomes a bit more accurate. With 1 million trials, even a smaller error, 0.01%. And finally, with 10 million trials, corrected 2 decimal places, we have an error of 0. Now let's see the program in action. When you run the program, this is the opening screen. We have our square and our circle. Over on the right, we select the number of hits, or the number of tennis balls to throw over here, and then click on Fire to begin the process. To have a new trial, we click on New. Let's suppose we start with 1000. Click on Fire, and you can see very quickly we've got the number of hits inside the circle, which is 783, and outside the circle on the green, 217. The estimate for pi, using the formula of the ratio, that we obtained earlier, we have 3.13200. Let's increase that, let's say, to 10,000. And very quickly again, we're obtaining a ratio that approximates pi to about, as you can see, 3.1372. A simple program to use, but very effective, and gives a good demonstration, visual demonstration of the Monte Carlo simulation. Please download it from my website, www.emathame.com. Until next time, bye.